Hello everyone. Today's topic is on Kirchhoff's current law. So it is shortly called as KCL. So Kirchhoff's current law states that algebraic sum of the currents entering any node is equal to 0. The node is not a circuit element. It cannot store charge. It cannot destroy charge. So KCL is simply based on law of conservation of charge. That is, charge is neither created nor destroyed. So mathematically I can represent it as n is sigma, n is equal to 1 up to n, in is equal to 0. Okay, where n is number of branches connected to that node. And in is nth current, which is either leaving or entering the node. So what I told, node cannot store consume or destroy charge. Charge is based on KCL is based on law of conservation of charge. KCL, this current leaving or entering the node can be compared to, suppose if you take pipes, they are connected in Y shape. You can't say that all the pipes are sending water. They're all positive currents entering them. Pipes might burst. Either this pipe must be sending some water, and then at this point water is leaving from these two pipes. This is one case. Or another case is, there might be a chance that these two pipes are sending currents, water, and it's leaving through this pipe. Okay, there is a case. That means if a current is entering node, it has to leave. So For detailed understanding, suppose consider node A and I connected four bytes. Suppose now this is my assumption. So let the current through this wire be IA, be IB, this be IC, and this be ID. Let's now there is a sign convention for case here. If the current is entering the node, current direction is considered as negative. Okay. Current entering the node is considered negative, and current leaving the node is considered positive. Okay. Now if you consider this node as O, so at node O, apply KCL. Now see, IA is entering, so its sign is taken as negative. Minus IA, IB is leaving. So according to KCL, algebraic sum of the currents at the node is equal to 0. IC is also entering, so take the sign as negative. Whereas ID is leaving, so take it as positive plus ID equals to 0. Now take this IA and IC to the other side, so we'll be getting IA plus IC is equal to IB plus ID. That means, okay, I can write sum of the incoming currents is equal to the sum of the outgoing currents, or sum of the entering currents is equal to the sum of the leaving currents. So sum of the incoming currents is equal to sum of outgoing currents. So let us take a simple example to understand it more briefly. Okay. So according to the, now I assume direction that, so see there is one node here, let this be node A. So apply KCL at node A. What I'll get? 4 amperes is entering the node, minus 4. I naught is leaving. So it is plus I naught plus 10 amperes is also leaving, equals to 0. So you'll get I naught as minus 6 amperes. If you're getting negative, that means the current is flowing opposite to your assumed direction. That's it. Thank you.